We're going to make a short review of Chapter 1 of the summer assignment here, starting with problem number 4. And what you want to consider with these problems is why are we considering this question? So here we are talking about significant digits and their importance in making measurements. And so the correct answer for A is going to be that when we mix 180.0 grams of sugar and 100.0 grams of water, those are described at a level of precision that means that we're going to be somewhat close to 280 grams. It could be a little bit more, it could be a little bit less. So you're probably going to choose a couple correct answers here. But it's not exactly 280.0 grams. It's a little more or a little less. 280.0 would describe the precision to which we know the answer, but of course it's a measurement, so there's a little more or a little less. Now in part B, the question is a little bit different because we're mixing a sugar that dissolves in water into water, and as the molecules combine, we're going to get a much different volume. Do you think that volume is going to be much greater or much less or somewhat less? That's what you're going to want to consider here in 4B. Number 5, when water boils, bubbles rise to the surface. So we're talking about water sitting on a hot plate or a stove or something. Here we have a picture of a beaker, and we see these bubbles that are rising. Usually they start down here at the bottom as small bubbles, and as they rise through the water, they get bigger. What is inside those bubbles? So what is the concept here, really? Well, the concept is, do you recognize that this is a physical change, not a chemical change? If it is a physical change, the water molecules, H2O, the water molecules are going to remain water molecules. And in fact, that's what the bubbles consist of. Are there other ways that this question might be asked? Well, yes, it turns out that last spring on the AP chemistry test, this question was asked. And a lot of people missed it because it was couched in this idea. The question was really asking about, do these bonds break when you boil? They used alcohol in that particular example, but when you boil a liquid, do the bonds break that hold the molecule together? Well, not if it's just boiling, not if it's just a physical change. So consider that for number 5. Now, if you need to stop and look at any of these longer, feel free, of course, just to pause the video. Number 6, you have a glass rod. Maybe you can hardly see that here. I'll underline it. A glass rod, we're holding it in a flame, and the glass rod appears to be turning black. So what is this question really asking? And how will you explain each of these changes? What type of change is happening to the wax? We're talking about the wax in the candle. What kind of change is happening at the wick? And that's this part right here. What kind of change is happening to the glass rod right up here? And it kind of describes that a little bit. It says it appears to turn black. How are you going to explain? Now, on the AP test, you're going to find that you can't just put an answer. You have to put more than a one-word answer. It takes an explanation. That was my explanation I gave a couple of years ago. And I think I have another explanation that I set up here. What is happening at the wax? Of course, it's important here to recognize that this is a chemical change. And at the wick is a chemical change, and there's an explanation for why. And at the glass rod is just getting warm, so that's a physical change. The black deposit there is carbon from the candle. Moving on to number 20. Give measurement data that are imprecise and inaccurate, and be sure and explain how to identify data that is inaccurate and data that is imprecise. So here we have some data that is imprecise and inaccurate. Let's see, what was the given measurement? I'm going back here a moment. The given measurements, you'll want to be sure and look that up. But what you see here is that none of these values lie nowhere close to what we need to get the correct measurement, and they also fluctuate. So inaccurate, because their percent error is very large, they're not anywhere close to the accepted value, and imprecise because there's a big difference in measuring 9.63 centimeters and 13.34 centimeters when you're measuring the same thing. So that's both imprecise and inaccurate. Here we're looking at precise but inaccurate. Now precise because these measurements are very close to the same, but inaccurate because they're not close to the accepted value. Once again, you're going to want to glance at the accepted value there in Chapter 1, Problem 20. Precise and accurate. So the accepted value must have been somewhere close to 10.6. So here we have precise and accurate. They are closely grouped, so they are precise, and they're close to the accepted value, so they are accurate. Percent error would be very low. Percent error is a measurement of accuracy. Can a measurement be imprecise and accurate? No. If that happens, it's not really a case of being both imprecise and accurate. It's you might have a case where you had a bunch of imprecise measurements that averaged together to be accurate, but that would be just because you were extremely lucky with your data collection.